Our three beginning questions are, how are social skills implemented in basic science? Can scientists discover flaws in their research by collaborating with others in similar fields? And what are the molecular mechanisms involved in an enzyme-linked immunosorbent assay?
Right now I'm working on 3 different projects, all of them relating to inflammation, and collaborating with various investigators looking at sleep apnea to osteoarthritis, and there's a lot of interconnection because of my interests in the whole inflammatory process and even infectious disease, because that's pretty much where I started, was in infectious disease.
Oh, we just never could have done the whole thing by ourselves. We just don't have that level of expertise in chemistry that we could have done it on our own. Anyway, who wants to do it on our own?
Once collaborating with other students, I discovered that I was able to get a new perspective on the subject and understand it in a new way.
Get the zoo back, get the zoo back!
I'm trying! I'm running out of Pokeballs! Oh man, I got it.
Actually, not that big of a deal.
Oh. Can I help you?
Hey, do you guys know the process in the ELISA assay?
Sure, I actually use the process in my lab.
Yeah, me too. Visuals made it easier for me to understand. Maybe we can go print a model in my lab.
Let's go. There are different approaches to an enzyme-linked immunosorbent assay, or an ELISA, but I will be demonstrating the capture or sandwich assay. Our application begins with coating the plate. This is when the capture antibody is absorbed to the microplate. If this were a ham sandwich, the capture antibody would be the first slice of bread. The plate is incubated at each step to allow for molecular interaction, and washed between steps to ensure that only specific binding events are maintained. Next, the plate is blocked to prevent nonspecific binding. This is when a substance irrelevant to the immune complex is added to the plate to cover any unsaturated surface binding sites. After blocking, the antigen of interest is captured. This is when the antigen specifically binds to the capture antibody. The antigen is like the ham in the sandwich. The next step is detection, when a specific biotinylated antibody binds to the antigen. The detection antibody is like the second slice of bread in the sandwich. Signal amplification comes next. This is when tetrameric streptavidin conjugated to an enzyme called horseradish peroxidase binds to biotin with high affinity. Streptavidin is like a toothpick at the top of the sandwich. Next, a substrate is added to the plate, which horseradish peroxidase catalyzes to produce a colored compound. The data is then quantified by a plate reader via spectrophotometric analysis.
Our 3 ending questions are, how do scientists collaborate internationally? How is 3D printing technology incorporated in optical science? And how are enzyme-linked immunosorbent assays modified to detect different disease mechanisms?